Projection of a vector. Draw two vectors m and n with an angle theta between them. So let's do that drawing. Here's n and here's m, and the angle between them is theta. If we create a right-angled triangle with m as the hypotenuse and the adjacent in the direction along n, like so, so we'll drop a perpendicular here. So this is a right angle, and we can see that m is the hypotenuse. The length of the adjacent is called the projection of m on n. So that's this length here, which I'm going to call P. If we know the angle between the two vectors, then P is quite simply the magnitude of m, which is the length of the hypotenuse, times cos theta, and that's just ordinary right-angled triangle trigonometry. If we only have the two vectors m and n, then we can find it using P is equal to m dot n over the modulus or magnitude of n. Let's just see how that works. Consider m dot n over n. That's the modulus of m times the modulus of n times cos theta by the definition of the scalar product divided by the modulus of n, and of course these cancel. Although the projection has a direction and is therefore a vector, we normally just give the magnitude of the projection as the answer. The way that I often think about this is think as m as being a stick put in the ground at an angle, and the sun is directly overhead. Its projection on the ground is the length of the shadow. Find the scalar projection in the direction 35 degrees of vector 10, 155 degrees. We're only given the direction here, but we may as well put this down as 1, 35 degrees by using a unit vector in this direction. We're saving ourselves a little on the working. So that's our unit vector there, and then the other vector is over here like this. So this is a unit vector, this one's got a magnitude of 10, and the angle in between them is 155, take away 35, so that's 120. Now the scalar projection is A dot B, we're projecting onto B usually, divided by the mod of B. So A dot B is the modulus of A times the modulus of B times the cosine of the angle between the vectors, and we're dividing by mod B. So those cancel, and we just have mod A times cos theta. So mod A is 10 multiplied by cos 120. Cos 120 is negative half, so it's negative 5. Now what the negative means here is that the projection onto this vector is actually this side rather than along the vector there itself. Now in this case we're after a vector projection rather than a scalar projection. The scalar projection of A on B is A dot B over mod B. All we do to turn that into a vector projection of A on B is multiply here by the unit vector B. What's more normal, however, is that we don't use the unit vector B, we use the actual vector B, not b squared, but b. We'll see where the squared comes in a moment. So if we think about b hat being equal to b over mod b, then b over mod b, this one is already over mod b, so that's where the squared comes in. So this is the formula usually used for the vector projection. So we're doing A on B, so we need A dot B divided by mod B squared times B. So that's going to be 7(2) dot 2 negative 5. Now the modulus of b is going to be 4 add 25, so that's root 29, and square that is 29. And then our vector b is 2 negative 5, so we just need to work this out. So that's going to be 14 take away 10 over 29 to negative 5. So that's 4/29 of 2 negative 5.